So I'm going to try something new for notes today. I'm actually going to use my iPad, so we'll see how well or not well this goes. Anyway, so we are going to edit this document. Oh, this looks different. Okay, we'll see if I can do this. Okay, so we're going to solve variables now with a variable on both sides. So I have no idea why this is not writing. Oh, there we go. So now we can see we have a variable on both sides. So in doing this, okay, again, we're going to distribute to remove parentheses if necessary. We're going to collect like terms. And lastly, or not lastly, we're going to move variable to one side. And lastly, we're going to solve. Okay, so that's the process that we're going to go through. We can see from the first first 6 here, that we're not going to have to worry about any parentheses. So we're going to blow this up as large as we can to take advantage of this. So I see I have a 5y and a 3y. Now this is just me and my own personal preference on dealing with variables on two sides. I'm always going to move the smallest one. I mean, I have a 5y on the left, I have a 3y on the right. So I am going to subtract the 3y so we can take the 3y to the other side. Okay, so that's going to be 5y minus 3y gives me a 2y. I've got that 8 there, so we're going to add 8, and we're going to add 8, so that gives me 2y is equal to 20. And then as what we've done previously, we're going to divide by 2, and find out that y is equal to 10. In example number 2, again, no parentheses, but I got a negative 6x on the left. I've got a negative 8x on the right. Technically, negative 8 is a smaller number, so that's the one I'm going to move. So we're going to add 8x, and we're going to add 8x. Okay? If I combine those, I am going to get a positive 2x. And that's the reason I always move the smaller one, because I get to, I'm going to end up with a positive number there. Okay, meaning a positive 8 and a negative 6. So that means that, I mean, if we could include, I jumped a step over there, because this is what we'd have if we just went ahead and did one step at a time. We're going to subtract the 14 to get 2x is equal to a negative 2. And when I combine the positive 12 and the negative 14, we're going to divide the 2 out of there, and it turns out that x is equal to negative 1. Okay. All right. 7k equals 3k minus 36. So again, I'm going to move the smaller one. The smaller one is 3k, so we're going to subtract 3k. So I'm left with 4k is equal to a negative 36. And here comes the, I want to say the kicker, but you got to make sure we're paying attention to details. That negative sign right here is got to stay with the 36. And the rest of this is definitely not any different. We're going to divide by 4 and get a negative 9. Okay. So this will be the first one we end up on the right hand side, because I'm going to take this negative 2u and we're going to add 2u maybe. Okay, so 12 is going to equal 11u plus 45. And we're ready to subtract the 45 over. So we're going to have 11u, and we're going to, we have a negative 45 and a positive 12, so we really end up subtracting those. So we're going to end up with a negative 33 there in the end. We're going to divide out the 11. So negative 3 is going to equal u. Okay. All right. We'll just keep on working these particular problems. We got a page, a couple pages of problems. We have an in-class activity to do, and we'll see where it goes from there. Okay. So here we go. Again, I don't know where I was. I lost track of my train of thought for a second here. I'm going to move the smaller one, so that means I'm going to add 6m, and we're going to add 6m, and so that means that I get 11 equals 51. Try again. All right, I'm getting a little ahead of myself. Got 11 plus 5m is equal to 51. That is horrible. Okay, being kind of sloppy on this one, my apologies. Subtract the 11 over, so we have 5m is equal to a 40. We're going to divide the 5 out of there. So m is going to equal 8. And on 6, I have choices. I'm either going to move the negative 10k or the negative 7k. Negative 10 is smaller. So that means I'm going to add 10k. Maybe that was so I can add. I don't know what that looks like. Definitely not a plus sign. So we're going to add 10k. So 1 is equal to 40 plus 3k. We're going to subtract that 40 over to get negative 39 is equal to 3k. We're going to divide the 3 out of there and find out that k is equal to negative 13. And do notice on this one, I know that I had the variable on the right and I switched it my answer. I wrote the variable on the left. That's going to be irrelevant. We can always use the symmetric property and flip that over. Okay. So that's where we stand on that one, and we'll move on to the next page. Okay, you can pause videos, so I'm just going to go ahead and move this up all the way. Now we're going to throw in some parentheses, and basically it's the second verse, same as the first. Everything is going to work the same exact way, except we're going to have an initial step of distributing to get rid of parentheses, and that's the only additional step. So we distribute the 3 to get 18p minus 3. And that's going to be 11p minus 45. So now we're at the same exact place we were on the front page. We've got a p on both sides. We're going to move the smaller of the two, so I'm going to subtract the 11p over. 18 minus 11 gives me a 7p. We are going to add the 3 and add the 3, so that means that 7p is equal to a negative 42. To get p by itself, we're going to divide the 7 out of there and find out that p is equal to a negative 6. Okay, all right. I mean, that is the process, except we just make it more convoluted on the next one because we have 2 sets of parentheses to get rid of. Okay, so 2 times 4 is going to give me an 8w. 2 times the negative 1 is a negative 2. Negative 10w will be the result of that product. Negative 10 times negative 3 is going to give me a positive 30. Do pay attention to that because that's a common mistake. And then we're going to add 4. Combining like terms, I mean, I got a 30 and a 4 to put together, but I can wait on that one. I'm going to go ahead and add the 10w over right now. So I end up with 18w minus 2 is equal to, and now I'll combine the 30 and the 4 to get 34. We're going to add this 2 over to get 18w is equal to 36. We'll divide the 18 out of there and find out that w is equal to 2. Okay. 9m minus 27 is going to be the first distribution, well, the only distribution, plus 3m equals 7m plus 43. 9m plus 3m. So remember, now that we're on the same side, we're just going to do what's sitting there. 9m is positive, 3m is positive. So that means I get a 12m to go. Minus 27 equals 7m plus 43. The smaller one is 7, so we're going to subtract the 7m to the other side, and that will give me 5m. I'm going to take care of a multiple step here. I know I'm going to add the 27 over and add the 27 over. So we end up with those canceling. The 7 and negative 7 cancel. So I end up with 70. So we're going to divide the 5 out, and we're going to divide the 5 out, and m is equal to 14. Okay? I wonder if I can pause this. Oh, I can't pause these. That stinks. Okay, negative 16 minus 14a minus 21 is equal to 23 minus 2a. Okay? So, man, I wish there was somebody to pause this. Oh well. So negative 16, negative 14a, minus 21, we distributed it correctly. A little sidetracked right now, so hopefully we did that right. So I'm going to go ahead and write this first, negative 14a. Got a negative 16 and a negative 21 to give me a negative 37. We've got 23 minus 2a sitting over here on the right. Okay, this one is the smaller one, so I'm going to add 14a to get negative 37 is equal to 23 plus 12a. Again, we're going to combine those constants, so we have to subtract the 23 over. So we end up with a negative 60 is equal to 12a. We'll divide the 12 out and find out that a is equal to negative 5. Two more problems to do here, and I think we jump into, a partner activity. No, we got some solutions to do here. Okay, so we have 5x minus, here we go, 5x. We're going to distribute the negative sign, would be a negative x and a positive 18. We're going to distribute the 2, so that's going to be a negative 2x and a negative 30. So we took care of the distributions. Again, be careful. That negative sign has to go to both of them. The common mistake is to leave that as a negative x and write that as a positive a negative 18 as well. So we have to do that. So in this case, though, since we have multiple x's on the left, I'm going to put those together. 5x minus x is going to give me a 4x. We got a positive 18. Over here we have a negative 2x. We have a positive 6 and a negative 30. So that's going to give me a negative 24. And now, again, I'm back to that same exact spot. We just got to collect some like terms. Negative 2 is the smaller one, so we're going to add 2x. So that's going to give me a 6x. I'm going to go ahead and we can practice doing multiple steps in one line. So I'm going to subtract 18. So that's going to give me a negative 42. And we can divide the 6 and divide the 6 and find out that x is equal to a negative 7. And the last example here, and then we'll get into some special cases. 8y plus 32 would be the distribution. Negative 2y plus 2 would be that distribution. And then we have 70 minus 3y. So 8y minus 2y is going to give me a 6y. A 32 and a 2 is going to give me a 34. So again, notice the difference. Everything here is already on the left-hand side. I'm not going to have to move anything by pluses and minuses. I'm just combining what's there. Okay? And you can't see my pen dashing around here. I just realized that. Oh, well. 70 minus 3y. So now it's combining things. I'm going to move the smaller y, so we're going to add 3y and add 3y. So that's going to give me a 9y. I'm going to subtract the 34 over and subtract the 34 over. So that's going to give me a 36. We're going to divide that 9 out of there and get y is equal to 4. Okay then. Now we're going to move on to a page of special circumstances, special solutions. We have to be aware of when we have a no solution and when we have an infinite solution, okay? So most of the time we work with conditional equations. A conditional equation means that there's one specific answer. There's this equation is true only on one condition, x equals 2, okay? But there's two other possibilities that we need to come across here, okay? If I went to solve this, I would end up with a negative 8x minus 4 is equal to a negative 8x minus 2. And really the telltale sign is we're staring at it right now. I've got a negative 8x. Why didn't that work? Yeah, freehand highlighter. Sorry, I'm learning the program. There it is. A negative 8x and a negative 8x. So I end up with the same thing on both sides. So what happens here is when I go to add 8x to get those on one side, they're going to end up canceling on both sides, and we get this statement of negative 4 equals negative 2. Well, that's false. There's no way. And if we think about this, what value of x can I stick in here so that I subtract 4 from it, and then I, on one side, subtract 2 from it on the other side, and get them to equal? Well, that will never happen, okay? So that is why this is in the no solution category. It's because I had a false statement. There is no value of x that will ever make it true, no matter what. Okay? The flip side of that is to have what's called infinite solutions. Okay? So let's see what that looks like. We've got a negative 5 minus 9x. We're going to distribute to get a 3 minus 9x minus 8. And I end up with a negative 5 minus 9x equals negative 5 minus 9x. So if we go ahead and grab my highlight tool, this one again, we have the negative 9x and we have the negative 9x, just like we did on the other one. We've got the same amount of variable on both sides. However, this one has a negative 5 and this one also has the negative 5. I end up with the same exact expression on both sides. And even if I forget that or don't notice that, if I add 9x and I add 9x, again, my x is canceled just like it did on the other side. You can't see me pointing at it. But we end up with negative, the difference is I end up with negative 5 equals negative 5, which is a true statement. So that means this is always going to be the case, because since both sides are the same, it doesn't matter what I drop in for x, both sides are always going to be equal. All right? So this is going to be something called all real numbers. And we give that a symbol. It's the double-legged R, okay? It's a capital R with two legs. Okay. And now we have 4 solutions here. So we have 4 more examples. We'll call it good, and then I wasn't thinking, and I don't have the solution for that. I'm not for sure what I'll do with that. So anyway, here we go. We have a 6x plus 6 minus 3x equals 6 plus 3x. If I combine like terms, I'm going to end up with a 3x plus 6 and a 3x plus 6. And again, because I have the same thing on both sides, that's going to, I mean, yes, I could go ahead and subtract and do all that fun stuff, but that tells me that I have all real numbers. It doesn't matter what value I put in for x, it's going to be true. Okay? So we got 12x minus 36. We've got a 14x minus 28 when we go ahead and distribute that. Okay? Now this one, it is just here to, I don't say not trick us up, but paying attention, I have a 12x on one side and a 14x on the other, so since I have a different value of x's, this one solves like any other equation does. We're going to end up with a 2x. Okay? I guess I could have been trading colors here. We're going to add the 28 over and add the 28 over, so that gives me an 8. And then we're going to divide the 2 out of there and divide the 2 out of there, and 4 is equal to x. So this is a conditional equation. It is only true if x equals 4. Okay. All right, 8 times 5 is going to give me a 40x minus 24. The other one's going to give me a negative 18x plus 24. Whoops. The joy of having an eraser now. I blew that because it is minus 24. Now I can see that, yes, I have minus 24s, so that's going to cancel out, but my x values are different. My x coefficients are different, excuse me. So I'm going to have a 58x is equal to, and again, just for a different color because I have another operation going on here, we're going to add the 24 and add the 24, and we're going to get 58x equals 0. So we're going to divide the 58 out of there, and we're going to find out that x is equal to 0. So, special cases, well, I hope we come across a no solution here because that'd seem awful silly not to. Anyway, we have 3x minus 13. We've got a 7x plus 14. We've got a negative 4x plus 28. So now we're going to combine some like terms. They are already on the right-hand side. So therefore, 7x minus 4x is going to give me a 3x. 14 plus 28 is a 3042. And so this, again, if we're grabbing this is going to be raising the red flag, okay, the warning flag. But we can see that I have a 3x and I have a 3x, so that's I got the same exact variable. Now I have to decide, is this all real numbers or is this no solution? But because on one side I'm subtracting 13 from that product, and on the other side I'm adding 42 to that product, there is no way ever for those to be equal, so therefore this is going to be a no solution. Okay, there's nothing in common for that. All right, so if you're in class, you're going to end up doing this activity together, kind of with us. When I go ahead and grade your packet, your homework packet, your note packet on completion, if you're a remote kid on this day, you don't necessarily have to do this. So I'm going to go ahead and stop myself now, and hopefully